Great. Okay. So I must admit I chuckled when I originally thought of the title of this talk, Your Server Will Be With You Shortly, because I was remembering being in Göttingen for sambaXP and dining at Sausalito's. So I was tempted to put this, Your Server Will Be With You Shortly, the Göttingen Sausalito's story. For people who don't know, we went out for dinner at Sausalito's for one sambaXP, and let's just say the service took a little while. So what I'm talking about today is something I don't often talk about, and that's actually Samba and Google. I'm a member of the Samba team. I'm also in the Google Open Source Programs Office. But Google actually pays me to work on Samba code, and Google actually uses Samba code. So I'm going to be talking a little bit about how Google uses Samba code, and a pretty interesting issue that ended up creating some large changes in Samba, or at least in some of the internals of Samba. Having said that, this is not a Google badge talk. There is no Google logos other than I think something I cribbed from Wikipedia for the Chrome OS logo. So please don't treat anything in here as being an official Google statement, etc., etc., etc. All right, let's begin. So what is Chrome OS? Oh, I can't see the chat while I'm doing this. Never mind. If anyone has got any burning questions, actually do feel free to unmute and ask them directly. I'll take questions obviously at the end of the talk. But right now I'm only looking at my own screen and my own picture, so I can't actually see if anyone has any issues that they want to talk about. So what is Chrome OS? If I was in a room, I would ask everyone who's used it to raise their hands. Obviously, I can't see your answers right now. So Chrome OS is a managed single-user desktop created by Google. It's actually based on Linux, and it's mostly open source. There are some parts that aren't. I don't want to talk about those. If you want the pure open source version of Chrome OS, there's something called Chromium OS, which is purely open source. So what does Chrome OS actually do? Well, it's different from a Linux desktop. All of the stuff that you would normally fiddle with essentially is built into Chrome OS, and it's trying to create a more user-friendly environment. So all the hard parts. The other thing is it's a managed environment. So all of the hard parts of managing a Linux desktop are essentially done by the Chrome OS administrator. They're not really done on the Chrome OS box itself. So setting the things up, deploying applications, setting everything up is done via the administrator in a remotely managed cloud-based web console. When Chrome OS is integrated into Active Directory, which is where Samba comes in, the devices are joined to Active Directory before given to users. Users aren't really asked to join Active Directory themselves. I believe they can, but normally they're just deployed already, joined to the directory. So if anyone, it's very, very popular in US schools. So for instance, my son in the pandemic is using a Chrome OS box, and we had to ask the administrators to remove access to Amazon and YouTube for obvious reasons, and also to stop weird stuff he'd been ordering turning up. So it's completely remotely managed. And the other thing about it is it's a single user device. So if you think about a normal desktop Linux, you have different users who can log on. They have different user IDs. That's not Chrome OS. Chrome OS essentially has one user identity, the person who logs in. Other processes have different user IDs, but they don't represent the user. So single user means that Winbind isn't needed. This took me a long time when I first started talking with the Chrome OS people to get my head around. They use process IDs they use user IDs as a method of isolation, not as actually representing different users. It's a little similar to the way Android works too. So you don't need Winbind, but what that means is one of the features that Samba depends on kind of isn't there. and that will come up a little later. So there's no real data held on the box. Everything is essentially cached, and the real data is held in the cloud, and that means you can essentially lose the machine, destroy it, relog on as a different user, and then relog on as the same user on a different machine, and it will synchronize all your data, which is very, very useful. Another place where Samba comes in is Chrome OS boxes. I think in 2018 gained the ability to access local SMB shares. But again, the idea is that you access the data on those shares from the box. You don't copy any of that data locally. So the use case is you can wipe and re-image the box at any time and you won't lose anything. So how does Chrome OS use Samba? So the first and the hard part is Active Directory integration. This has quite a few moving parts, which I'll go into in a little while. This is complicated. And using Samba essentially was an easy choice for them because A, I'm there working at Google, and we have a long history of actually integrating really well into Active Directory. One of the interesting features about the Chrome OS choices is that no NTLM has been allowed. Chrome OS is engineered for as much security as Google can manage, and therefore they only allow Kerberos. There's no fallback to NTLM whatsoever. And the other thing that Chrome OS uses Samba for, as I've already mentioned, is to do remote SMB file share access. And that, again, that's libSMB client, again, kind of a no-brainer. We have a long history of doing this right in many different environments. It's also, I forgot to note that in the slide, it's SMB2 only, no SMB1 integration. They want to keep their things as secure as possible. And as Ned said, friends don't let friends use SMB1 anymore. Ned Parr from Microsoft said. So how does it actually work? Well, when a user logs in to a Chrome OS box joined to Active Directory, there's a bunch of C++ code that then drives, all of this C++ code is publicly available in the Chromium OS repositories. So if you want to look at it, you can take a look at how it drives it. But it actually then starts calling a bunch of Samba code, and the Samba binaries that it calls, just unmodified Samba binaries in a sandbox, which I'll talk about in a little while, are netads workgroup gets the workgroup info for the realm, netads info, which gets the KDC IP address, which we then use to populate a temporary curb5.conf, netads lookup gets the KDC name, then we do the kinit to get the initial Kerberos ticket granting ticket. Then we do a netads search, which is an LDAP search to get the user information. And all this stuff is essentially parsed by C++ code from the output from the Samba binaries. Excuse me. Then we use netads GPL list to get the group policies, which we then parse and feed into SMB client commands, which then download the group policy files and apply locally for the changes that make sense for the Chrome OS configuration. Now, the interesting thing about that for Samba is that we actually use a bunch of caches. Well, actually, one cache. I think this stuff is mostly put into GenCache, which is our generic caching area. And because of the sandboxing, those caches get wiped between commands. So, you know, this means that we're not taking advantage of some of the things, some of the cache data that we should have. We have to refetch each time, which will come into the issue that I'm going to describe in a little while. So the sandboxing of the file system can make the preserving caches difficult. So some of the quirks inside Chrome OS. When Samba is run, how it's invoked when the Samba binaries are invoked, the C++ code essentially makes an inter-process communication, a dbus request. And then it runs a command called minijail. Again, you can take a look at all this, and then runs a allow list of system, which runs an allow list by a binary called setcomp. And essentially, when this was being created, the Chrome OS team went through Samba and they worked out every single system call that the Samba binaries needed to make, and they explicitly allowed those. So that what that means is if Samba goes crazy, or we have a bug, or someone managed to exploit Samba, it's restricted to the system calls that Samba is expected to make. And also minijail restricts the access to a file system, to the areas of the file system that it's supposed to access. So it's like it's not quite a virtual machine. It's a set of binaries that essentially control, for security purposes, what the Samba binaries can do. And I think this is used for many things within Chrome OS. When Chrome OS wants to invoke something, it's run under minijail, and things have to be allowed to make specific system calls. So what this means for Samba is that many of the normal things that we kind of expect, oh, we can do this, we can do that, we have access to various parts of the file system, they're no longer true, and they have to be carefully crafted. So this is very secure, works really well, but it also means it's kind of fragile against changes in the Samba code. They have to requalify Samba versions as they get put into Chrome OS. Let's see. Hello, am I? There we go. Oh, there we go. So let's start to describe what went wrong. A large customer, and I'm afraid that's all I'm going to be able to say about the customer. They were large. They were very large. And they loved Chrome OS. Everything was working great, except for one site. They had one remote site, and they could never get any users invoked who were enrolled in Chrome OS Active Directory. Nobody could log on. All the other sites worked great. That one site. Now, having said that, it was a very desirable site. If I could have, if it wasn't within the pandemic, I would have actually loved to go on that site to help them debug it. But so it was somewhere I could have vacationed quite happily for quite a long time, but didn't get to go. Everything was done remotely. But all the other sites worked fine, but not this one. So what was the symptom of the problem? Valid user would log on, enter their credentials. They would sit there with a little spinning wheel for about 4 minutes and then go back to the logon screen. So this was somewhat frustrating. Every other site worked fine, just not this one. So of course, now the engineer comes out, what's different about this site? What's going wrong? Well, this site has no local DNS server. All the other sites did, but not this one. Okay. So it's probably going to be DNS. As everybody knows, DNS always sucks, excuse me, on all customer sites. So, all right, it's a DNS issue. We probably know this much. Excuse me. Oh, dear. Keeping hydrated. Keep hydrated when you're talking. So what information can we find out from the customer? Well, should be easy, right? It's just a DNS problem. Great thing about the customer, incredibly helpful, incredibly knowledgeable IT staff. They were able to get me full Wireshark traces between the Chrome OS and any server it was talking to. Couldn't log on remotely and run GDB commands, and that's kind of hard under Chrome OS anyway, but the other great thing about Chrome OS is that it's very easy for the customer to turn on a feature where they return complete Samba debug level 10 logs. Do a simple terminal command, zips them all up, they can ship it out with one email. This is great. Should be easy. We can fix this. We've got all the information we need. We have the Wireshark traces. How hard is this going to be? So, if it's a DNS latency issue, which it probably is, there's DNS mask. Now, for a previous issue, I was pulled into Google and actually added DNS serve record caching to DNS mask for the version 2.81. This was an earlier Chrome OS thing I worked on. And so I actually worked upstream, got caching serve records, the upstream maintainer of DNS mask rewrote all my code, of course, but hey, what the hell? The feature got fixed, and that's the main thing. So yeah, well, let's just make sure we're running the right version of DNS mask and everything should be fixed. Oh, it turns out that even after all that, there were some internal arguments about what they should allow, and DNS mask ended up not making the cut. There were, I don't remember the exact details. There were some issues about, well, you know, what if people are using this as a method to communicate by asking for certain names and basically some security information leakage? Should it be system-wide? Should it be just associated with the user? And it didn't make the cut, basically. So I'm like, oh, okay, that's a pain. All right, well, we've got to fix this inside Samba. So it's not going to be so easy. Okay, let me look at the logs. So when you're trying to find a KDC Active Directory domain controller, you do a lookup for name underbar Kerberos.tcp and then the customer name realm. It was returning over 200 names. Oh, they have a lot of ADDCs. And the 200 names coming back didn't have the IP addresses associated. They were just a list of names coming from the serve record. Serve records can have IP addresses associated with the names, but this one did not. These requests did not. Oh, so what that means is Samba now says, oh, okay, I got a bunch of names. Let me find out the IP addresses. And I took a look at the code. And we do this sequentially. Every single one of these 200 names get header info. And we would do it for IPv4. And then we would do it for IPv6. And we don't do anything else until every single one of those names gets resolved. We only need one. We don't know which one. It has to be a working one. We don't know which of these ADDCs is actually up and running. So we have to resolve all the IP addresses before we can start talking to them. Oh dear. So the problem is DNS name lookup in Samba was not very scalable. So what do I have to do? I have to make it fast and resilient, and I have to make it scalable. I mean, so the goal was make it scale to hundreds of DNS servers simultaneously and thousands of simultaneous names, and do it for both IPv4 and IPv6. So Samba shouldn't have to do this. You should be able to make these calls into the operating system, and the operating system DNS resolver should be able to do this for you. I mean, otherwise you end up every single application on the system has to reinvent a fix for this problem if they're trying to do scalable DNS lookups. So POSIX sucks, I'm afraid, yet again. Get_Info doesn't really work for this. And interestingly enough, glibc, but not FreeBSD or any of the other systems that Samba runs on, has Get_Info A, which actually creates a thread pool inside of glibc, the C library, and makes thread-based Get_Info calls. So it's kind of not solving the problem. So what we really need for scalable DNS is a different API that applications can use. And I have some ideas on that. I'm going to talk about that at the end of the talk. So when you're in this horrible hole, let's start digging into the code. So Volker, who's a Samba team member, he'd already anticipated this problem. This is something he'd worked on before, and he built on top of earlier work by Kai Blin. As I said, the Samba team is a great collaborative environment, and many times what you're looking for may already be somewhere in Samba. One of my favorite science fiction authors, Vernor Vinci, came up with a job in one of his future science fictions of set many thousands of years in the future of programmer archaeologist. And that's pretty much what we have in Samba, is that, you know what, the code base is big enough and old enough that if you look somewhere and do some archaeology, there's probably something that's kind of close to what you need. So I found this, and we have great DNS record lookup code. It's modern, it's asynchronous, it talks to multiple DCs in parallel, and it wasn't being used. Not in the NetADS code lookups paths that Chrome OS was needing. So, okay, well, maybe I can make this work by plumbing this fantastic scalable DNS async interface into the parts of Samba that are used by Chrome OS. So, many thanks to Ralph for this slide. Another CERNET Samba team member, Ralph Boehm, he actually had to dig into this for a customer. And so he created this call graph of where this was being used and how it was being used. And it's over-designed is a polite way of talking about this. As you can see, it does end up in DNS lookup send eventually, but it's not an easy thing to get to. And it took a while to figure all this stuff out. So let's start coding. So I must confess, I took advantage of Google a little bit in that there's some really old, horrible code in Samba dealing with name lookups. So under the guise of this bug, I essentially modernized a lot of this stuff. So I got rid of the malloc, talloc mixers, moved everything to talloc, cleaned up a bunch of stuff. Noel from Susie also helped me get a lot of this upstream. So I have a great deal of thanks for him. And essentially, we already have the pieces that we need. The existing asynchronous DNS lookup code kind of works. It's really good. It has some things that are missing I'll talk about in a little while. And just plumb it into the name resolution code inside of namequery.c, which is our main name lookup code. And it was actually a lot easier than I thought it was going to be, this part, because this async DNS code is actually really, really nice. It will read your resolve.conf. It will hit all of the DNS servers in parallel, which is something that Volker needed, because the system resolver asks each DNS server in turn. If one of the servers is down, the first one, it takes ages to fall back. It just wastes all this time. I added a default 10-second timeout. So essentially what the code looked like now is that you want to name lookup, you hit all the DNS servers in parallel, you do both A and quad A records for IPv6 and IPv4 simultaneously. You collect everything you can coming back, and if whatever you don't get back after 10 seconds, you just throw away. And that should be enough. We've got 200 to choose from. One of these should work fine. So now I got cocky. Now I thought, oh, hey, this is great. I have this new function. It's great. It's fast. It's scalable. Let's use it everywhere. Yeah, okay. So I was really happy with this function, and I thought, let's do it. Let's replace all name resolution in Samba with this. And you know what? I actually got it to work in the real world environment. Where I couldn't get it to work was in the test harness. And I actually figured it out eventually. The problem is we actually mock, we have an emulator for our DNS requests, and we interpose at the glibc layer, and this is resolve wrapper. And resolve wrapper doesn't interpose for the new async lookup functions. So another thing people may not know, we actually have a DNS server inside Samba as part of the test environment, again written by Volker in Python. And so I thought, you know what? The resolve wrapper talks to that. Maybe I can hack the Python DNS server. And I got so close. I nearly made it work. but there were one or two tests that I could never ever get to pass, and so I thought, okay, let's scale back my ambitions. Let's just fix the customer problem, and fixing a test environment is a task for another day. But we have the capability to do this, so it would be nice to see it finished in the end. So this is great. We did lots of local testing, spun up test environments locally, added a test framework in Chrome OS for this, gave it to the customer, can't log in. Oh, all right, well, what's going on? All right, let's take a look at the logs again. And it turns out that the new DNS async resolver code uses readv, the readv system called for scattergather, when the DNS replies are very large, and so we have to fall back from UDP, the connectionless interface, to TCP for large replies. And the mini jail sandboxing had read in the allow list, but not readv. Okay, well, let's just fix that, give the customer another version. Customer still cannot log in. Okay. Now why doesn't it work? Well, let's see. Not our fault this time, not entirely Samba's fault. So again, more logs. Let's take a look. One of the things that we hadn't tested or tested differently is that the user on this problem site is logging onto a trusted domain, not the domain that the machine was joined to. And Chrome OS's setup for Samba was missing a domain SID. And so what was happening, we were going into our token creation code. A domain SID is a machine identifier or domain identifier. And we need that. Interestingly enough, we need that internal for the Samba code. Chrome OS doesn't use it at all, but the Samba code expects it to be there. And so this framing code, the C++ framing code, wasn't setting this up for trusted domains. So they still couldn't log in. So we fixed that. Okay, that works. Tested locally, logging into a trusted domain, everything works great. Gave it to the customer. They still can't log in. Okay, so hang on a second. So what I'm going to do is I'm going to switch to, at this point, I'm getting a little frustrated. So one of my favorite movies is an old movie from the 1970s. I'm going to share a different screen. Here we are. This should work a little better. Okay. Just to give some context, this 1 minute video clip just sums up engineering frustration better than any other clip I've ever seen. Science fiction movie done by John Carpenter called Dark Star. I really encourage everybody to watch it. It's a great movie. It's really funny. And this is how everybody was feeling. Can everyone see the? I'm back to seeing the comments. Can anyone see the beginning of the video setup? This is how everybody was feeling at this point.
Jeremy, we don't hear anything.
Uh-oh.
So when you start the screen sharing, you have to hit the box where your computer sound is also with the video.
Hang on a second. Whoops. Oh, wait a minute. Hang on a second. Okay, so let me see if I can go back to Zoom. All right, so I start screen sharing. Share computer sound. Thank you so much for that. Okay, now it should work. All right, let's try again. This is how everybody was feeling.
Begin primary sequence. Mark at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, drop.
Negative drop. Just sitting there in the bomb bay. Try it again, Pinback.
Mark at 5, 4, 3, 2, 1, drop.
Negative drop. Reach out one more signal. Get all explosive bolts activating on the port side. Get over there. Put a log disk LT515 in an operation position. And then remark.
Mark at 5, 4, 3, 2, 1, drop. Drop.
Okay. Hang on a second. I'll get back to. Oh. Hang on a second. Fighting with Zoom. I need to start current slide and okay. Sorry, trying to get back to. Okay, share screen there. Okay, right. Sorry, we're back to the beginning, but let me quickly move to there. Yes, so work, damn you, drop. It's not like we were sitting with a thermostellar bomb in the bomb bay, but we were pretty frustrated at this point. So I love that. I love the scene where everything is calm and then everybody works frantically and they try one more time. This was pretty much where we were. So all the Samba code is working great. So what's wrong now? Okay, K in it. And the Wireshark traces were the key because it showed what was issuing this. The MIT, even though we have everything we need, we've put everything in the curb5.conf. When it's a trusted domain, the MIT curb5 library is also doing serve lookups. It does it for underbar Kerberos, underbar UDP, underbar Kerberos, underbar TCP, and then it again looks up every name sequentially using get header info for IPv4, then IPv6. And for some reason in the code, it's doing this 3 times. So Red Hat to the rescue. Thank God for old Samba Team code. Gunter Deschner, working at Red Hat, wrote an MIT curb5 Kdc Locator plugin in Samba. And the reason for this was actually to use Winbind to find the closest DC, because Winbind should know where it is. And now that Winbind uses async DNS, this should be easy. It would fix it. But Chrome OS doesn't have Winbind. So at this point, in just desperation, I took a merciless hatchet to the code, created something that directly called a Samba function, get KDC list, and just linked whatever I had to link to get this to work. And so finally, 2 months later, the customer could log on. The most nice, calm, patient customer, even though very large, I've ever worked with. I was so lucky to be able to work with someone that nice. And it took us 2 months. But they could log in. Now they can roll out new Chrome OS updates, and the customer is happy. So, what did we learn about this kind of thing? So, anyone who's ever done customer support should know these things, I guess. But it's really interesting to write them down in a world of open source and many, many complex code interactions. First of all, logging. If we hadn't had the logs, if Chrome OS didn't have a way to get us those logs, we would still be working on this. We could never have fixed this bug. Getting the logs with the Wireshark stuff too was completely essential. Second thing, source code for everything. So being able to look at the source code for the Chrome OS driver, the source code for minijail, for setcomp, and the source, obviously the source code for Samba, but the source code for MIT also, that would show me what it was doing and why it was doing what it was doing, was essential. If we'd just been using a proprietary Kerberos library that was doing this, again, we could not have fixed this bug. Network debugging. Having a customer who can run Wireshark. I mean, you don't always get this, but to be honest, even with the logs, because we couldn't get the logging out of MIT Curve 5 without adding another logging framework, having the Wireshark tracers enabled us to fix this. Without the Wireshark tracers, we wouldn't have known what the Kerberos libraries were doing. And finally, well, hire open source engineers. I know this is touting people working here, but without someone who knew the code intimately, and I had also worked on the MIT Kerberos code back in around 1997, so I was actually pretty familiar with that. Without someone who's knowledgeable about the source code, again, just sort of, this is why having the source code and having someone who knows the source code is really, really useful and essential. Because if you're just sending support requests to a third-party vendor whose source code you're using, again, something as complex as this with as many interactions probably would not have gotten fixed. So Samba's in the DNS client business. We have all this code. And I would like to get out of the DNS client business if we could. We have many, many things to do inside Samba, and having to maintain everything with modern DNS isn't something that we really should be in the business of doing. You know, I mean, DNS over TLS is coming. We do have DNS sec implementation, but DNS isn't static. It changes. Modern uses of it are different from the uses that we originally wrote the code for. But the POSIX DNS interfaces utterly suck. They really do. Single static name lookup, get adder info. It's not fit for purpose. So what should it look like? Now, you know, I know some people don't like it, but systemd is the key. And I found some of the systemd source code, resolve control.c, may already have the kind of features we need. It does actually interprocess communication, uses dbus, I think. But over a socket would be really handy, file descriptor based. Essentially what you want to be able to do is what our DNS async lookup code does. You want to be able to say, for all DNS servers that you know about, here are a list of names, a list of lookup types, go away for n seconds, look those up, come back with what you've got. And a file descriptor based interface that can notify asynchronously the caller saying, hey, I have some results, come pick some up. Maybe reuse the get adder info structures linearized over the socket to make it easier for client code to use it. That's what DNS should really look like. And at that point, all the browsers don't have to do their own DNS lookups. Samba doesn't have to do its DNS lookups. You know, Kerberos doesn't have to do the DNS lookups. We can actually outsource this to one well-maintained binary, which is probably going to be the systemd, at least for Linux. And that would be great. I think that's what it should really look like. Okay, so that's all I have, and I've got about 5 minutes for questions, comments. Slides available, that isn't done, unfortunately, but hopefully it Cernet already has the slides. I'm sure they'll be able to make them available for anyone soon. Okay, so let me go back and anyone, let's see. Okay. Anyone got any questions? And I'm happy to take them in chat or over the microphone. Oh, Alexander comments that systemd resolved is not a panacea. Oh, thank you, Alexander. It's a panacea for me because it's not my code, so I don't have to maintain it. So let's see comments. Okay, so right, here's comments from Gunther. So Gunther, thank you. Why I wrote the second locator. Now you understand why. And Andreas says, I'm an idiot, and we have MIT curb5 traces already inside Samba log files. Didn't see that. But remember, Andreas, we were running Kinit. So Kinit does not have the traces, or at least we hadn't turned the tracing on there. Okay, Steve wants to know how to query the time to live for a DNS record. You know, I'm not sure how to do that. I would have to look at the DNS protocols to find out. I believe it does return that information, but I would have to check. Okay, so does anyone else have any questions or comments? And Volker mentions, shouldn't a local caching resolver do much of what's needed? Yes, DNS mask would have solved this. That's why I wanted them to use it, and I put the server record caching in. So essentially, a local caching resolver, even so, you can only ask the caching resolver, given the POSIX APIs, you can only ask it sequentially. And so, you know, the ability to ask for many names at once is actually a very useful thing to be able to do. Yeah. So I answered that question. And yes, and as Volker points out, over UDP on localhost, we can say, we don't need DNS over TLS, etc., etc. Yes, this is true. But it's kind of, I would still prefer a more modern interface where you don't have to depend on, we're talking to a local resolver that's caching and therefore we don't have to add any security. It would be nice to essentially have an API that just was more modern, essentially. Okay. So yes, I would have loved it had the customer just spun a DNS server up at the site, but you know what? It's their site; they get to choose. We just have to make it work. But it did, in fact, improve Samba significantly, and I think Andreas has done some testing, or at least looked at this and found that it has improved our domain join abilities quite considerably. And Samba is much more scalable in an AD environment now. And Andreas saying, I'm still an idiot. And yes, if Samba does the Knit, Samba was not doing the Knit. The Chrome OS framing code was, calling code was doing the Knit, not us. And again, that's mini-jail again, and you know, having to recreate all the file system environment for each command. So actually, I'm kind of out of time. Does anyone have any more questions or comments?
I have a question.
Jeremy. Yes, thanks, Alexander.
I will ask in audio. So this means the way you describe it, how Chrome OS works this. This means that you do not support KDC proxies. So you do not support logging in over the Kerberos proxying protocol that, for example, Microsoft implements on their sites.
I don't know. That's something
because you cannot discover it with the existing locator plugins and with the way how you discover the DCs over the net ADS requests.
Okay, so Alexander's comment is this is not going to work with a new Kerberos feature. So that's something that you and I could maybe discuss offline and maybe with the Chrome OS team. So that's, again, that's something we could possibly work on if we want to make sure that this works right. Most of these things are customer driven. So we have not yet had a customer who's complained, hey, I can't work with my DCs at all. So I just haven't had to dig into this. But it would be very good to have a discussion with you about what's needed there. So thanks.
Yeah, we can do that later.
Sure. Thanks,
during the conference. Thank you.
Yeah.